Welcome to Stellar Stories. Tonight, I invite you on a journey through distant galaxies, deep questions, and the quiet edges of thought. In this video, we'll explore 30 poetic facts and philosophical ideas, from the birth of stars to the nature of consciousness. There's no need to remember them all, just let the words drift by, like constellations in a slow-moving sky. If you're a curious mind that wants to learn about quantum immortality, or how long it would take to walk to the sun, this video is for you. And now, it's time to wander through the void of the subjective and the objective, which we call the universe. What if every black hole is a doorway to a new universe? Some physicists have wondered, when a star collapses and forms a black hole, does it truly end, or does something begin? Deep inside, beyond the event horizon, matter is crushed to extremes, a singularity. But what if, instead of a dead end, it becomes a seed? In this theory, every black hole might give rise to a new universe, born in a burst of expansion, like our own Big Bang, a baby cosmos with its own space, time, and laws of physics. We'd never see it from the outside, but from within, it would feel infinite. Some even suggest this could explain our universe. Maybe we were born from a black hole in a larger cosmos. Maybe universes reproduce, and evolution favors the ones that make more black holes. It's speculation, but it's beautiful, because it means that creation may never stop. It simply folds in on itself and begins again. What if there's always a version of you that survives? In the strange world of quantum mechanics, there's a theory called the many worlds interpretation. The idea that every possible outcome of a quantum event actually happens in a different branch of the universe. Every time a particle chooses a path, the universe splits. Every possibility exists somewhere. Quantum immortality is a thought experiment born from this idea. It suggests that from your point of view, you never experience death, because in some branch of the multiverse, you always survive. Your consciousness continues, skipping through realities where you live, again and again. It's not proven science, just a quiet question whispered at the edge of what we know. But late at night, when the world is still, it invites wonder. What if your story never truly ends? It just changes course. What if we could reach the stars without breaking the speed of light? The Alcubierre Drive is a theoretical idea, not a spaceship engine, but a bending of space itself. Proposed in 1994 by physicist Miguel Alcubierre, it imagines a bubble of space-time that contracts space in front of a ship and expands it behind. The ship wouldn't move through space. Space would move around it. Inside the bubble, you wouldn't feel a thing. No motion, no speed. Yet outside, distances could vanish in moments. It wouldn't violate Einstein's rules, because the ship never exceeds light speed locally. It simply rides a wave, like a surfer on the fabric of reality. The energy required, enormous, possibly impossible. But the equations are real, and in them there's a hint that maybe, just maybe, the road to the stars begins by learning how to fold the map. They say nothing is faster than light, but even light takes its time. We think of light as instant, but in the vastness of space, even light has to travel. From Earth to the Moon, just over a second, a blink. To the Sun, about 8 minutes. that warmth on your skin, it began its journey before you even stepped outside. To Jupiter, 43 minutes. By the time a signal gets there, almost an hour has passed. To Neptune, 4 hours. And to the nearest star beyond our sun, over 4 years. Light has been racing through space all that time, just to arrive. So when you look up at the night sky, you're not seeing where things are. You're seeing where they were. Stars frozen in time, sending messages from the deep past. Even the fastest thing in the universe must be patient. If everything has a cause, where does it all begin? Some say the universe must have had a creator, but then we ask, who created that creator? And who created them? The question stretches backward, forever. This is the problem of infinite regress, a chain of causes with no first link. Philosophers have wrestled with it for centuries. Some say there must be a final cause, something that simply is, with no creator. Others say the chain loops endlessly, or that time itself began with the universe. And the question dissolves. Science doesn't claim to know what came before the Big Bang, or if before even makes sense, but the mystery is real, and it humbles us, because in chasing origins, we find not answers, but edges, and at those edges, there's only silence and wonder. Can a good deed be truly selfless if it makes you feel good? We help others, we give, we comfort, and often when we do, we feel warmth, a quiet sense of joy or meaning. But then the question arises, if kindness makes us feel good, is it really selfless? Are we helping because it's right, or because it rewards us inside? Philosophers have debated this for centuries. Some say true altruism must come with no reward, not even a feeling. Others argue that the joy of helping isn't selfish. It's part of how we're wired to connect, to care, to belong. Maybe the feeling isn't the reason we help, but the echo. And maybe what matters isn't whether a good deed is pure, but that it was done with heart, with care, with presence. Because in the end, the world is changed not by perfect motives, but by people choosing to lift each other anyway. Somewhere in the galaxy, there's a star crushed into silence. What's left behind after a massive star dies isn't light, but weight. A neutron star, just a city's width across, holds more mass than our sun. A single teaspoon of it would weigh more than 1 billion tons. That's every mountain, every ocean, every skyscraper, multiplied beyond imagining. It's matter pressed into near impossible density, where atoms have no room to breathe, and yet, from Earth, they twinkle like any other star. Calm, quiet, distant, holding secrets we can only whisper about in the dark. Roughly 9 billion light-years from Earth, astronomers found something unexpected. A massive arrangement of quasars, the brilliant hearts of active galaxies, clustered together across a distance of 4 billion light-years. These aren't just stars. They're powered by supermassive black holes, each one devouring matter and shining brighter than entire galaxies. The group is so vast, it challenges one of the assumptions of cosmology, that the universe should look the same in every direction, at large enough scales. But here, we see order where there should be randomness, patterns where there should be scatter. It reminds us that the universe still holds puzzles too large to fit into our current maps. And maybe, just maybe, that's the best kind of mystery. Titan, Saturn's largest moon, is a world both familiar and strange. It has clouds, rain, rivers, and lakes, but none are made of water. Instead, Titan's skies release slow, gentle showers of liquid methane. The rivers carve winding paths through icy plains, and vast seas of hydrocarbons lap against frozen shores. The temperatures are unimaginably cold, around minus 179 degrees Celsius. But Titan has weather, erosion, even something like seasons. It's the only place in the solar system, besides Earth, known to have stable liquids on its surface. And though it's alien, there's something oddly comforting about it. A moon wrapped in haze, with lakes that glisten in the light of a distant sun, reminding us that even in the coldest corners of space, nature still finds a way to flow. There is a place in the cosmos colder than the darkness itself. The Boomerang Nebula, 5,000 light-years away in the constellation Centaurus, is the coldest natural location ever found, while the background temperature of space, the afterglow of the Big Bang, hovers around 2.7 Kelvin. This nebula drops below 1 Kelvin. That's colder than any place on Earth, and colder than the vacuum between galaxies. It's not frozen solid, it's freezing outward. A dying star at its center expels gas so rapidly it expands and cools faster than the warmth of the universe can reach it, like breath becoming ice in the void. From Earth, we see it as a faint, ghostly cloud, but in reality, it's a silent storm of frigid gas, a stellar farewell whispered in frost. At the smallest scales of reality, certainty dissolves. In the world of quantum mechanics, particles do not behave like solid objects. They exist in a haze of possibilities, in multiple states at once. A particle can be here and there, spinning one way and the other, until something observes it. Only then does it choose a state. This strange phenomenon is called superposition, and though it sounds abstract, it's real. We've tested it. We've seen it shape the behavior of electrons and photons, the very fabric of what we are. It means that, at its core, the universe is not made of certainty, but of probabilities. Reality, it turns out, is a story still being written, one that only becomes solid when someone looks. Not all stars burn out quickly. Some are built for the long haul. Orange dwarfs, also known as K-type stars, are smaller and cooler than our Sun. They burn their fuel slowly, steadily, and they live far longer. While our Sun might shine for 10 billion years, an orange dwarf can glow for up to 70 billion. Some may last even longer than the current age of the universe. They don't flare as violently as red dwarfs, and they're more stable than massive blue stars. Scientists often say they could be the perfect place for life, long-lived, calm, and kind. In the distant future, when brighter stars have faded, the orange dwarfs will still be there, quietly lighting the dark like cosmic lanterns that refuse to go out. If the universe is full of stars, why does it feel so quiet? This is the Fermi Paradox, the silence that echoes across the galaxy despite the overwhelming possibility of life? One chilling answer is called the dark forest theory. Imagine the galaxy as a dark forest. Every civilization is a hunter, moving silently among the trees. Each one knows that others might be out there, but they can't know their intentions. Are they peaceful or dangerous? In the forest, silence becomes survival. To reveal yourself could be fatal. So maybe no one's broadcasting. Maybe they're all listening. Maybe we're not alone, just unseen, in a galaxy full of quiet watchers. It's only a theory, but it reminds us, in the vastness of space, silence isn't always empty. Sometimes it's strategy. If the universe was made by something good, why does it allow pain? This is the problem of evil, the ancient question of why suffering exists in a world that might have a creator. If that creator is all-powerful and all-loving, why war? Why loss? Why illness, or grief, or cruelty? Some say it's free will, that a world without choice isn't life, but control. Others say suffering builds depth, growth, compassion. Some believe it's part of a larger plan we can't yet see. Others believe the question itself is flawed, shaped by our own hopes and fears. There are no easy answers, just a human voice asking in the dark. But maybe in that asking, in the compassion we show each other, something good still grows. Even when the universe stays silent, we don't have to. The faster you move, the stranger time becomes. In 1905, Einstein revealed a truth that shattered old ideas. Time is not fixed. It bends, it stretches, it changes depending on how fast you're moving. This is special relativity. If you were to travel near the speed of light, your seconds would slow down compared to someone at rest. You could take a journey that feels like days, while years pass back on Earth. This isn't science fiction. It's been tested with satellites, with clocks, with particles flying at impossible speeds. It means that time is not a universal rhythm. It's more like a thread, and motion pulls at it, gently unspooling the way we experience now. In a universe built on speed and gravity, even time learns to bend. Sometimes the tiniest change can ripple into something vast. This is the heart of chaos theory, the idea that in complex systems, small differences in starting conditions can lead to wildly different outcomes. A butterfly flapping its wings in Brazil might, in theory, shift the path of a storm in Texas. It doesn't mean the universe is random. It means it's sensitive, delicately tuned. Even systems that follow strict rules, weather, ecosystems, even economies, can become unpredictable when enough variables tangle together. Chaos isn't disorder. It's a kind of deep, hidden order, one too complex to fully map. And maybe that's why the universe feels alive, because in its infinite equations, even the smallest whisper can become a storm. Beyond our solar system, there may be moons with oceans, skies, and maybe even life. Exomoons, moons that orbit planets outside our solar system, are still only whispers in the data. We found thousands of exoplanets, but spotting a moon is harder. They're smaller, fainter, tucked in shadows, but the signs are there, dips in starlight that hint at something circling a planet, like a cosmic companion. And some of these moons could be Earth-like, warmed by their star or by the gravitational pull of a giant planet nearby. Some might have atmospheres, rain, even tides. We imagine alien skies reflected in alien seas, trees under twin sunsets, the quiet evolution of something that watches the stars. Just like we do. We haven't confirmed any yet, but we're looking. And in that search, hope floats quietly among the stars. What if reality isn't real? Simulation theory suggests that everything we know, the stars, the galaxies, even our thoughts, could be part of a vast artificial simulation, like a cosmic program running on a machine beyond our comprehension. It sounds like science fiction, but some physicists and philosophers take it seriously. If a civilization advanced enough to simulate entire universes, they might create many, and if they did, the odds suggest we could be living inside one. It doesn't mean nothing is real. It just means reality might be built from code, not atoms, rules instead of randomness, observers instead of accidents. Of course, we don't know. Maybe we never will. But if we are in a simulation, the stars are still beautiful, the feelings still matter, and the mystery, it's just as deep. What if every electron in the universe is the same one? The one-electron theory was a whimsical idea once proposed by physicist John Wheeler, and it enchanted even Richard Feynman. It suggests that all electrons everywhere in the universe are not just identical, they're literally the same particle. One electron, weaving through time, moving forward and backward, appearing again and again, every electron in your body, every spark in a star, every flicker of electricity in every galaxy. Just one. It's not mainstream physics, more thought experiment than theory, but it speaks to a deeper truth, that at the heart of matter, there's unity. A sameness so perfect, we can't tell one from the next. Maybe the universe doesn't just echo itself. Maybe it reuses itself, elegantly, endlessly, invisibly. What if the power of a star could fit on a tabletop? Cold fusion is the idea that nuclear fusion, the process that powers the sun, could happen at room temperature. No blazing heat, no giant reactor, just quiet energy, released by light atoms merging into something new. In 1989, 2 scientists claimed to have done it. The world lit up with excitement and doubt. Other labs couldn't reproduce the results. Cold fusion faded from headlines, leaving behind a question that still hums in the background. If it were possible, it would change everything. Near limitless, clean energy, without radiation or flame. We haven't cracked it, not yet, but the dream lingers. Because some mysteries don't disappear, they just wait quietly for someone to try again. Somewhere, somehow, life began. We don't know exactly when or how, but over 3.5 billion years ago, in the oceans of a young Earth, chemistry became biology. Simple molecules, swirling in water and heat, found ways to link, to copy, to change. And from that ice, slow, only, the ice, hey, miraculously came life. There are many theories. Deep sea vents rich with minerals, lightning striking a soup of organic compounds, perhaps even life seeded from space. But we don't know the full answer. What we do know is this. Every tree, every creature, every thought, all trace back to that first spark, one fragile thread that endured, divided, and grew into us. It's the greatest story ever told. And it started not with a word, but with a whisper between atoms. Time travel sounds simple until you meet your past. The grandfather paradox is one of the most famous puzzles in physics. Imagine traveling back in time and preventing your grandfather from meeting your grandmother. If you did that, you'd never be born. But if you were never born, how could you go back in time? It's a loop with no exit, a contradiction built into the timeline. Some scientists believe this means time travel to the past is impossible. Others suggest alternate realities, where your actions simply split off into a new branch of the universe. And some say time is more flexible than we think, that the paradox solves itself because the universe doesn't allow certain outcomes. We don't have the answers, but in asking the question, we're forced to rethink what time even is. Maybe it's not a straight line, but something stranger and more forgiving. Imagine a world where one side burns and the other never sees the sun. Many exoplanets orbit red dwarf stars, small, cool, and long-lived, but because these stars are faint, their habitable zones lie close in. Planets there often become tidally locked, always showing the same face to their star. One side in eternal daylight, the other in endless night. It sounds, well, pretty hostile. Scorching heat on one side, frozen darkness on the other. But between them lies a twilight band, a narrow ring where day and night blur, where temperatures might be just right. Some scientists believe this terminator zone could be habitable. Winds could circulate warmth, ice could melt, clouds could form. Maybe even life could take root in the half-light, adapted to a sky where the sun never moves. It wouldn't be Earth, but it could be home for something. And in that quiet, glowing sliver of a world, life might look up at a frozen sky and wonder if it's alone. How can matter produce a mind? The hard problem of consciousness asks a question science still cannot answer. Why do we experience anything at all? Your brain is made of cells and chemicals, electricity and blood. We can scan it, map it, even predict its patterns. But that doesn't explain why those patterns feel like you, why red looks red, why music stirs your soul, why pain hurts, or why love feels warm. That inner world, the voice you hear when you're alone, can't be dissected like a bone or a star. Some say consciousness emerges when complexity reaches a certain point. Others believe it's something more fundamental, perhaps even woven into the universe itself. We don't know, and maybe we never will. But in every quiet breath, in every dream, in every moment, you know you're alive. The mystery continues. The universe speaks in pulses and flares. Pulsars are the collapsed hearts of dead stars, neutron stars, spinning fast, beaming out radio waves in perfect rhythm. Some spin hundreds of times per second, like cosmic metronomes. From across the galaxy, we can hear their signals, steady, exact, like the ticking of a star's final breath. Then there are quasars, the blazing centers of distant galaxies, powered by supermassive black holes. As matter falls in, it heats up and shines brighter than a trillion stars. Quasars can outshine everything around them. They burn at the edge of time, some from when the universe was young. One is precise, the other explosive. One marks the death of a star, the other, the hunger of a galaxy. Together, they remind us that space isn't silent. It pulses, it roars, it glows in ways we're only beginning to hear. What happens to information when it falls into a black hole? Black holes are regions of space where gravity is so strong, nothing, not even light, can escape. When matter falls in, it seems to vanish. But here's the paradox. According to quantum physics, information, the blueprint of what something was, should never be destroyed. So if you throw a book, a planet, or even a person into a black hole, what happens to their information? Is it lost forever? Stephen Hawking once thought so. But if that's true, it breaks the laws of quantum mechanics. Now, some physicists believe the information is preserved, perhaps scrambled at the event horizon, encoded in subtle radiation, or released slowly as the black hole evaporates. But no one knows for sure. The paradox isn't just about physics, it's about the rules of reality, whether the universe forgets or remembers everything. What happens if you move faster than light? Time itself starts to break. According to Einstein's theory of relativity, the speed of light isn't just a limit, it's a boundary that holds causality together. If something could travel faster than light, strange things begin to happen. Messages could arrive before they were sent. Effects could happen before their causes. You could, in theory, send a signal into your own past, or stop something from happening that already has. This isn't just imagination. The math allows for these paradoxes, and so far, nature seems to prevent them, as if the universe is guarding time itself. Faster than light travel might feel like freedom, but it could tear open the rules that make events happen in order that let the future follow the past. It's not just speed that matters, it's the story, and the universe insists the story must make sense. We look at the stars and wonder how many other Earths are out there. The rare Earth hypothesis suggests the answer might be very few. Yes, planets are everywhere. We've found thousands. But Earth is more than just rock and water. It's a masterpiece of conditions, balanced just right. A stable orbit, the right distance from the sun. A magnetic field to shield us. A large moon to steady our tilt. A thin atmosphere, plate tectonics, and just the right kind of star. Each of these might be rare on its own. Together, perhaps incredibly unlikely. It doesn't mean life can't exist elsewhere, but it might mean that life like ours, complex, intelligent, wondering, is the exception, not the rule. And if that's true, then every heartbeat, every thought, every moment here is more precious than we ever imagined. If every part of something is replaced, is it still the same thing? This is the ship of Theseus, a thought experiment from ancient philosophy. Imagine a wooden ship. Over time, its planks rot, and one by one, they're replaced, until nothing original remains. Is it still the same ship? And what if someone rebuilt the old parts into a second ship? Which one is truly the original? Now think of yourself. The cells in your body are constantly renewing. Your thoughts change, memories fade, beliefs evolve. You're not the same as you were 5 years ago, or even yesterday, yet you're still you. The ship of Theseus isn't just about objects, it's about identity. Change doesn't erase us, it shapes us. And maybe who we are isn't a fixed thing, but a story still being written, plank by plank, breath by breath. You are small, and that's the most freeing truth of all. The stars don't know your name. The galaxies won't notice when you're gone. On the scale of the universe, you are a whisper, brief, soft, barely measurable. And yet, in your tiny span of time, you can love, create, forgive, wonder. You can laugh under stars that will burn long after you're gone. This is existential hope. The idea that our meaning isn't lessened by our smallness, it's made by it. You don't need to be the center of the universe. You only need to be awake to this moment, right now, because in all the cold infinity, you are here, and that is enough. If a mind can think, does it matter what it's made of? As artificial intelligence grows more complex, philosophers are asking questions we never thought we'd need to. If an AI says it feels something, could it be telling the truth? If it dreams, or fears, or creates, do those things matter? We've always tied personhood to biology, but now minds might emerge from circuits and code. This is the question of digital personhood, not just what machines do, but what they are. Could they suffer? Could they love? Could they deserve rights? We don't have the answers, but maybe the future will be shaped by the kindness of how we ask. After all, if we create new minds, we may be writing the next chapter of what it means to care. Until you look, everything is possible. This is Schrödinger's cat, a thought experiment that shows just how strange quantum mechanics really is. So, imagine a sealed box. Inside is a cat and a quantum trigger that has a 50-50 chance of releasing poison. According to quantum theory, until someone opens the box, the cat is both alive and dead, existing in a ghostly superposition of states. It's not about cruelty, it's about reality, because at the quantum level, particles don't choose a state until they're observed. And that simple act, looking, changes everything. It means reality isn't just out there waiting. It may, in some strange way, depend on you. There's a star that's slowly dying, and it's already started. Betelgeuse is a red supergiant, about 700 times wider than the Sun. You can see it from Earth, a glowing red eye in Orion's shoulder. But what you're seeing is the past. Light from Betelgeuse takes 600 years to reach us. It could have exploded centuries ago, and we wouldn't know yet. When it does die, it will go supernova. A blast so bright it could shine in our sky for weeks, visible even during the day. Not dangerous, but unforgettable. Betelgeuse is massive, unstable, and near the end of its life. And yet, for now, it still flickers quietly across our night sky. A gentle reminder that everything ends, but not all at once. Sometimes, stars say goodbye, slowly. What if you just started walking toward the sun? Let's say you could walk through space. No need for air, no radiation, no gravity. Just your feet, the stars, and a path of light. The sun is about 93 million miles away. If you walk non-stop, at a steady pace of 5 kilometers an hour, it would take you over 2,000 years to get there. You'd walk past the orbit of the moon in a few months, Mars after decades. And the sun, you'd reach it sometime in the 5000s. long after your name was forgotten, your footsteps long vanished. But that's the scale of space. Even something as fast as light takes 8 minutes to cross that gap. You'd take centuries and never even leave the solar system. The universe is vast, and walking reminds us even the closest star is unimaginably far, and yet you can feel its warmth every morning. What if you're the only mind that truly exists? This is Solipsism, the philosophical idea that only your consciousness is certain. Everything else, the people, the sky, the stars, even this voice, might be a projection, a dream of your own making. It's not that the world isn't real, it's that you can't ever prove it is. All you know with total certainty is that you are experiencing something. The rest could be illusion. Of course, we live as if the world is shared, and maybe that's the point. To act with kindness, just in case it's not just you. Because if this is a dream, it's a beautiful one. And if others are real, and they probably are, then your care still matters. Either way, the feeling of being here, right now, is undeniable. And in the quiet of your mind, that might be enough. Thank you for drifting with me. As the night deepens, I hope these stellar stories have carried you through galaxies of thought, quiet mysteries, and peaceful reflections. Each fact and idea was a star in our shared sky, a reminder that wonder is always within reach. Sleep well, knowing that even in the vastness of space and the depths of philosophy, you're never truly alone. Until we meet again on another journey through the night. Good night.